Solve y double prime plus 2y prime plus y equals 5, where y of 0 equals 6 and y prime of 0 equals 0. This equation is non-homogeneous, so to solve it, we need to find the complementary solution and a particular solution. First, solve the complementary solution, y double prime plus 2y prime plus y equals 0. The characteristic equation is k squared plus 2k plus 1, and we can factor the left side as k plus 1 squared. So there is one repeated root, k equals negative 1. This makes the complementary solution yc equals c1 e to the negative x plus c2 x e to the negative x. It's important to note at this step that it's too early to try to find the values of the arbitrary constants, since the initial conditions apply to y equals yc plus yp, not just to yc. Next, we need to find a particular solution. We will learn specific techniques to accomplish this later, but for this problem, we can use logic to figure out what yp needs to be. What kind of function, when you add it to its derivatives, gives a constant function? How about another constant function? After all, the first and second derivatives of a constant function are both 0, so if y is a constant, then y double prime plus 2y prime plus y will just equal y. Once we realize that y double prime plus 2y prime plus y equals y for a constant function, then it's clear that if we want y double prime plus 2y prime plus y to equal 5, then we should use yp is the constant function 5. Now that we have yc and yp, we can put them together to get the general solution. Y is yp plus yc, so y is 5 plus c1 e to the negative x plus c2 x e to the negative x. Finally, since we are solving an initial value problem, now that we have the complete general solution, we can apply the initial conditions. It's a second order equation, so we need two initial conditions. Y of 0 equals 6, so 6 equals 5 plus c1 e to the 0 plus c2 0 e to the 0, so c1 equals 1. Y prime of 0 equals 0 is a statement about the derivative, so we need to differentiate our general solution. Whether we choose to plug in that we know c1 equals 1 or not at this point is our choice. So y prime is going to be 0 minus c1 e to the negative x plus c2 times e to the negative x minus x e to the negative x, which equals negative c1 e to the negative x plus c2 e to the negative x minus c2 x e to the negative x. So 0 equals negative c1 e to the 0 plus c2 e to the 0 minus c2 0 e to the 0. So 0 equals negative c1 plus c2. So c1 equals c2 equals 1. Plugging in c1 equals c2 equals 1, we get our final answer of y equals 5 plus e to the negative x plus x e to the negative x.